Good afternoon, geometry students. I hope that everybody is doing well today. We are beginning our next chapter. We are going into chapter 4, and this is going to be all about congruent triangles. But before we get into specifics of congruent triangles, we need to be just a little more broad and talk about congruent figures. So today, I'd like for you to be able to recognize and identify congruent figures as well as their corresponding parts. So right here we have a table. I'm just going to talk a little bit about congruent polygons and what are they. So first of all, I just want to let you know that congruent polygons, they have all corresponding sides and angles are congruent. So if you have congruent polygons, then their corresponding sides and angles are congruent. So here we have an example where triangle ABC is congruent to triangle DEF, and we're going to identify the corresponding angles as well as the corresponding sides. What I want you to notice though, when we name these, the corresponding angles such as A and D are in correlating positions. So because A is parallel to D, or congruent, notice they are both in the first position. Now, they don't necessarily have to be in this position, but they just have to be in corresponding locations. So I'm going to make a little note of that. Notice corresponding vertices are in the same order. And that's going to be like that for every shape that you have that is congruent to something else. So now we're going to do our corresponding angles. We can look at the image or we can look at our congruency statement. So I know that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. I then want to do corresponding sides. So the corresponding sides are also going to be in corresponding positions. I can look at the image or I can use the congruency statement as well. So I'm going to say segment AB is congruent to segment DE. Segment BC is congruent to segment EF. So here I have B to C, it has 2 lines, and from E to F, it also has 2 lines. So that's how I'm getting that those two are congruent. And then I have segment, let's see here, I need AC. So from A to C is congruent to from D to F. And that's all we needed to do for that top part of the table. We're going to do the same thing down here. It's just now we have a rectangle instead of a triangle, but it still works the same way. However, you should, even though you might say, oh, but all 4 angles are congruent, not all sides are congruent. So the order does still matter. So P is going to correspond with W. Q corresponds with X. Notice how it's the first one in each listing, the second one, third, and fourth. So that's how we're going to correspond those. So corresponding angles, angle P is congruent to angle W. Angle Q is congruent to angle X. Angle R is congruent to angle Y. And angle S is congruent to angle Z. I got that straight from my congruency statement. I can also do that same thing with the sides. So I could say PQ, those are the first 2 letters, must be corresponding with WX. So I now know that segment PQ is congruent to segment WX. Segment QR is congruent to segment XY. Segment RS is congruent to segment YZ. And then to get my last one, I'm going to say first and last. So PS and WZ. So segment PS is congruent to segment WZ. All right, so just one more time. When figures are congruent, all of their corresponding angles and all of their corresponding sides are also congruent. So in this example, it says, given triangle PQR is congruent to triangle STW, identify all pairs of corresponding congruent parts. So that means list all the angles that are congruent, list all of the sides that are congruent. So the angles will be easy. I'm going to say angle P is congruent to angle S, angle Q is congruent to angle T, angle R congruent to angle W. How did I do that? I said P is in the first position and S is in the first position, so they must be congruent to each other. Q is in the middle and T is in the middle, so they must be congruent to each other, and so on and so forth. Now we'll do the sides, and remember to name a side, I need 2 letters. So I'm going to say PQ and ST, because these are both the beginning 2 letters of that congruency statement. So I have PQ is congruent to segment ST, QR is congruent to segment TW, and segment PR is congruent to segment SW. And that's everything it wanted for that problem, so we are moving on. In example 2, we are told that triangle ABC is congruent to triangle DEF. So we're going to use that information to solve for some missing values. So I have AB is congruent to DE, and then AC and DF. I'm just marking on the triangles what I do and don't know about them. Now it says find the value of angle X. So X is right here, 2x minus 2, and it represents between A to B, this part of this triangle. That is going to correspond with this part that is between DE on the other triangle. Now, if they are congruent, then that means their values are the same. If their values are the same, then I can set them equal to each other. So I am going to say 2x minus 2 is going to equal 6. And then I'm going to start solving like anything else that I would. So I'm going to add 2 to both sides. I have 2x is equal to 8. Divide by 2 on both sides, and I get x is equal to 4. So there's my solution for that first one. Next, it wants me to find the measure of angle F. Okay, angle F is right here, and F corresponds with C. So I am not told F by being told C, but what I can do, I know that B is congruent to E, so I could say, oh, hey, this guy is also 53 degrees. So now I have 53, 90, and an unknown inside of a triangle. I can add them up and set them equal to 180. So I have 53 plus 90 plus the measure of angle F is equal to 180 degrees. That gets me 143 plus the measure of angle F is equal to 180. So the measure of angle F is going to equal 37 degrees. So all we did was substitute in an equivalent value and then set the angles of the triangle equal to 180. All right. So as we continue working, we also have this theorem called the third angles theorem. Now, the third angles theorem tells us this. It says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles are also congruent. So let me say that again. We've got 2 triangles. We know that we have a pair of congruent angles right here and right here. But not only that, let me get another highlighter here. We also have a second pair in each of the triangles that are also congruent to each other. Now, if that's the case, then we must then conclude that the remaining angles, and in this problem, angle N and angle T, must also be congruent. So my conclusion, if I have L congruent to R and M congruent to S, then my conclusion must be angle N is congruent to angle T. So let's put that into action. It says find the missing angle measures in the given image. So we're going to try to find the value of x and y and L and N, I believe. So I have some markings on my triangles, and I'm going to fill in anything that I already know. Notice that M has one arch on it, and Y also has one arch on it. So that means these guys are congruent, so Y must be 88 degrees. So I'm just going to write over here, measure of angle Y is equal to 88 degrees. We have one of our answers already. Not only that, I also have this 50 that has no markings on it, and this N that has no markings on it. So I can then say, oh, hey, those two must be congruent as well. So I'm at this point where I have 88 is congruent to 88 and 50 is congruent to 50. Now I need to figure out what X and L are. So measure of angle. Alrighty, so I can use my third angles theorem and say, okay, whatever this one is, this one must also be. The angles have to add up to 180 degrees. So I'm going to say 50 plus 88 plus measure of angle X is going to equal 180 degrees. So this gets me 138 plus the measure of angle X is equal to 180. I just added these two up. Then I'm going to subtract 138 from both sides, and I get the measure of angle X is equal to 42 degrees. Now, if X is equal to 42 degrees, notice the markings, and that means L must also be 42 degrees. So I'm just going to write that underneath as well and box in both of them for that. Okay. We have one more example, example 4, and I know it's everybody's favorite. It is a proof, but you'll be glad to know that it is not that many steps. It's only 5 steps. Likely because of how long this given statement is. It says given PR and QT bisect each other, and let me put a line above. That should be segments. So segment PR and segment QT bisect each other. Angle PQS is congruent to angle RTS. And I need symbols once again. QP is congruent to RT. We are going to try to prove that triangle QPS and triangle TRS are congruent to each other. Well, the way that we're going to do that is first by getting everything organized. So it says PR, which is from here to here, and QT, which are from here to here. So those are the diagonals. They bisect each other. So remember, bisect. If you don't, then you should write this down. Bisect means to cut in half perfectly. So that is a very important piece of vocabulary that is not going away. So that means that this half and this half are congruent to each other, as well as this half being congruent to that half. I cannot say that these all 4 are congruent to each other. It might look like that in the image, but just because something is cut in half or just because 2 things are cut in half does not mean that their halves are the same. So for example, half of a cookie is not the same amount of calories as half of a cake. They're both cut in half, but their halves are not equivalent. So that's why we cannot say that all 4 of these are congruent. And then it also says that angle PQS, which is PQS, is congruent to angle RTS. Okay, so this guy and this guy are congruent to each other. And it says that QP from here to here is congruent to RT from here to here. So I'm going to put 3 lines there. All right, so that's everything that I know based off of the given so far. So I'm just going to write all of that out. So I'm going to say step 1, PR and QT bisect each other. Angle PQS is congruent to angle RTS, and segment QP is congruent to segment RT. All of that, why do we know it? Well, it was given to us. For step 2, we were given that there are bisectors. So remember, when something is a bisector, it's cutting something perfectly in half, which means that we can write a congruency statement. So now I'm going to say PS is congruent to SR. And QS is congruent to ST. And why do I know that? That is the definition of bisect. So now we have 3 sides of the triangles being congruent to each other and 1 angle. We can get another angle being congruent to one another this way. Notice, and I will go ahead and trace the 2 triangles that we're trying to prove congruent to each other. We're trying to get this guy and this guy congruent to each other. But notice how right here in the middle, I have vertical angles. So that means QSP and RTS are congruent. So I am going to say angle QSP is congruent to angle RST. Why are they congruent? They are vertical angles. So now I have these 2 guys being congruent to each other, and I also have these 2 guys being congruent to each other. Well, if I have 2 pairs of angles that are congruent to each other in 2 different triangles, that means that the 3rd pair of angles, which is going to be this guy down here and this guy up here, they must also be congruent to each other because of the 3rd angles theorem that's at the top of this page that we just talked about. So I'm going to say that angle QPS is congruent to angle TRS. Why? Because of the 3rd angles theorem. So now I'm at a point where I have 3 pairs of sides that are congruent to each other, as well as 3 pairs of angles that are congruent to each other. Because all the sides are congruent and all the angles are congruent, I can then say, triangle QPS is congruent to triangle TRS based off of what the definition of a congruent figure is. Remember, the definition of a congruent figure is all corresponding sides and angles are congruent. And we have proven that and shown that in this problem. So we are going to say, why are they congruent? Definition of congruent figures. And there you have it. That is the end of today's notes. I hope you have a wonderful evening, and be sure to bring questions to me to class tomorrow. Have a good night. Bye.